Let me introduce you null values. Sometimes in some column, like example salary in this employee table. So I don't know what to write. Example, let's say there is a one person called employee ID 1, his name let's say Raju. This employee's salary, let's say at this moment is undefined. That means nobody knows. Then we have to write something here. So that's why we use null value. So null to say that. So we don't know the salary of Raju. Sometimes what happens, there are some fields. This is one reason we use null value. We don't know the value at this moment. Sometimes it is not applicable. Example, let's say we are giving provident fund. Okay. So provident fund value for Raju is let's say 5,000 rupees. So there is another employee Rani. She is let's say contract based employee. That means she is not a full-time employee. For her there should not be any provident fund. So at this moment, so provident fund is not applicable for her. I write null values. So there are two reasons generally people write null values. One is unknown value. That means value is not known. Second reason is not applicable. So these are the reasons not applicable. Okay, so let's say whatever the reason doesn't matter. Let's say in your table if you have null values, then so your logic should be changed. That means so far we are assuming that we have only two logical elements. One is true, second one false, but these two are not sufficient. The reason, when there is a condition with null values, then we have to introduce one more logical element, that is unknown. So we'll see what is the reason for unknown and when we use unknown element. Okay. So now we have three logical elements. From now onwards, when we have null values, then we use three-way logic to solve the problems. True sometimes, false sometimes, unknown sometimes. When your condition will become true, when your condition will become false, and when your condition will become unknown, we will see. So let's start with some simple conditions. Example, let's say you have some expression like this, otherwise a condition like this: salary greater than 5,000. If the salary is 2000, then you know that 2000 greater than 5000 is evaluated to false, correct? So it's not a big deal. We know that. If this value is 7000, we know that the logical element is true, correct? So that means when salary is 7000, 7000 greater than 5000 is true. Now, if that salary value at this moment is null, then null greater than 5000 is what? Is the question. Since we don't know this null value, that means it is unknown value, then unknown greater than 5000 we can't decide. That's why it is neither true nor false. That's the reason we introduce element called unknown. From now onwards, null greater than 5000 kind of conditions are evaluated to third logical element called unknown. Second thing, example, you have some expression or some multiplication like this, x into 5, where x is nothing but let's say salary. Okay, so what about this kind of thing, salary into 5? If salary is let's say 5, 5 into 5 is 25. So we know it. For general values we know, but what if salary value null? So null into 5 is what? Remember one thing, any expression like any operator if you have, so null into that null into 5, otherwise null plus 5, null minus 5, anything, everything will be evaluated to a value called null. Sir, I am confused between unknown and null. Null is a value. Unknown is the logical expression. That means it's a logical element. It is because of the null values. So example, null values are used in the comparisons. Then the truth value will become unknown. So here the truth value is unknown, but null is a value. There is a difference. Example, if you write 4 less than 6, 4 is a value, 6 is a value. But this expression is evaluated to a truth value called false. True, correct? 4 less than 6. Similarly, when you have a null value, null is actually a value. Null greater than 6 or null less than 6. So all these expressions are evaluated to unknown. That is the difference between unknown and null. Okay, usually most of the times, so you get unknown element because of the conditions which involves null values. So that's thing. Second thing, in multiplication, example, there is a multiplication of salary into 5. Then multiplication gives you value, correct? That's why it's not about true false kind of thing. So the question is, what is the value of salary into 5? So either it is integer, if salary is integer, then if salary is null, then you get null. So finally, null into anything is null. You get a null value. That is about, getting null values. So you may get null values sometimes, you may get unknown values, right? Unknown is a logical element. There is a difference you should understand, correct? So when multiplication is involved between two values, then the result is a value like integer, correct? Otherwise null value. But when there is a comparison between two values, then that will lead to a logical element called true, otherwise false, otherwise unknown. That's it. So that is the connection between unknown and null values. Now we will see expressions. So far we have seen that whatever the condition we have, so that condition will be evaluated to either true or false or unknown, correct? So that is one thing you realize. Second thing, whenever you have an operator between two column values or one column value and a value, then that will lead to sometimes null value, otherwise simple values, like as you know that, right? Now let's see what is expressions. Example, you have some condition and another condition to C1 and C2, like this, C1 and C2. So in SQL we write like this, C1 and C2. Maybe otherwise you have C1 or C2. When you have C1 and C2, we know that this condition 1 will have, generally whenever there is a AND operator, so the left side and right side are logical elements. That means they will take truth values like true, otherwise false or unknown. Now in the presence of true, false and unknown, what is C1 and add C2? What is C1 or C2? We'll see one by one. Example, you have condition number 1 like this, salary greater than 5,000 and salary, let's say, less than 6,000. So what is the truth value? If salary is, let's say, 6,000, we know the answer. 6,000, let's say, just assumption, 6,000 greater than 5,000 and 6,000 less than 6,000. So here for value 6,000, 6,000 greater than 5,000 is true as usual, and 6,000 less than 6,000 is false. So now true and false will be evaluated to what? False. We know that, correct? So here you don't get null because null is a value, right? So here this is not a question of, it is not about getting null values. Here it is about AND operator. Whenever you have AND operator, before left side of that and right side of that will be logical values. So that's why they will be something like true, sometimes false, sometimes unknown. When that kind of logical elements are involved, what is the resultant answer? So here especially answer is false. If salary value is null, what happens? We'll see. Null greater than 5,000 and null less than 6,000. When you encounter null in the expression, how to treat it? How this will be evaluated is a question. Null greater than 5,000. So already I told you this is evaluated to what, right? So this is evaluated to unknown, correct? Unknown, and null less than 6,000 also unknown. Null versus anything is unknown, right? So that's why unknown and unknown is the final answer. What is unknown and unknown? You should know. That's why let me tell you at this moment, unknown and unknown is actually unknown, but let me tell you complete details one by one. That means unknown and false is what? True and false, of course you know. True and unknown is what? Unknown and unknown is what? Everything we will see as a table. So these are the details about unknown and truth values, like unknown and unknown. From now onwards, remember, it is evaluated to unknown. If you have unknown one expression and another expression is false, so unknown and false equal to dash is a question. Remember, it is AND operator, right? So AND operator is evaluated to true only if both of them, left side and right side expressions, are evaluated to true, correct? So already this is false. So if this unknown value is true, then unknown and false and true will be false, correct? If unknown value is, let's say, known and it is true, then false and true is false. And if unknown is false, false and false is false. So it is not depending on unknown value, correct? So irrespective of this unknown value, then unknown and false supposed to be false. That's why. So it should be false. Now, if it is unknown and another one is true, Now you will try to understand the answer for it. Actually, true and true is true. True and false is false. So it is depending on this unknown value. If this unknown value is known, we know the answer. If unknown value is true, I know the answer. If unknown value is false, I know the answer. But at this moment, I don't know whether it is true or false. That's why the overall expression's result also unknown. That's why remember from now onwards, unknown and true is unknown. Okay. Now let's see OR operator. If you have unknown, are unknown, then it is evaluated to what? Unknown. Very simple, right? So you don't know this one, you don't know this one, then overall truth value also you don't know, right? Second one, if you know first one, let's say true or unknown, so one of them is true, so it's very easy. At least one expression should be evaluated to true. That is the meaning of OR operator, correct? When there is a OR operator, one expression is already evaluated to true. That is enough to say that overall expression is true. That's why this unknown value doesn't have any significance here. So that's why it is evaluated to true. Now false. False or unknown is what? Very simple. So if this unknown is true, then false or true is true. If this unknown value was false, then false or false is false. At any time we can find out, but we don't know what is unknown at this moment. Then this overall expression's truth value we cannot find out. So at this moment it is depending on this unknown value which we cannot know at any time. So that's why I say the logical element for false or unknown is unknown. Now you see, whenever there is a unknown value, it doesn't mean that always that expression which contains unknown is unknown. See here, unknown and false is false, unknown or true is true. That two things you should remember, right? So any expression which contains unknown doesn't mean that that will give you unknown result, right? Sometimes it may give true result, sometimes it may give false result. This is the data. Now example, you are evaluating this kind of expression, not of unknown. What is this not of unknown? You have not operator, let's say, and unknown. So that should be evaluated to what? Not of true is false, not of false is true. But this unknown value is neither true nor false, correct? So that's why we don't know what is this unknown value. So unknown's opposite is, let's say, if I take false, what happens? I will tell you. This is not convincing. Why? Not of unknown is false, then not of, again if I apply not, what happens? You see, not of unknown supposed to be unknown, correct? So when I apply two times not, then I should get same truth value usually, right? That is what my intention. Then not of false is actually true. I am applying not at two sides, not of false, not of unknown. Really, so not of unknown gives unknown, not of false gives true. You tell me unknown is equal to true? No, that's why. So don't apply not of unknown and don't say it is false. That's why not of unknown should not be false and it should not be true. So it should be unknown, right? Remember it. So not of unknown is unknown. That means you don't know some value. Okay, so that means you don't know the truth value of it. Then the opposite of that also you don't know. That's it. Not of unknown is unknown. So these are all things which you should remember while evaluating the expressions. Example, you have SQL expression. In that expression you got this kind of logic, unknown or unknown. That kind of expression you have encountered. Then you remember that the result is unknown, right? Now, sir, in generally we write expression where? In where clause, right? Okay, I have an expression. You tell me now, when this corresponding tuple, because we know that whenever where condition is evaluated to true, generally, then that select class expressions or columns in select class will be printed, correct? So that is usual fact. Whenever where condition is true, we print them. But in the presence of null values, what do you want to say? Simple. Still the idea is same. So if this expression now in the presence of null values, this expression is evaluated to three things. One is your expression may be true, your expression may be false, your expression may be unknown, correct? So if it is true, then only print the column values. If the expression's result is false, otherwise unknown, in whatever the case, don't select the tuple. So tuple will be rejected. That's it. Okay. So we'll see one example of this kind of problem. Okay. You see this example. Select count star from EMP where salary greater than 5000 or salary less than or equal to 5000. What is my intuition is here salary greater than for any tuple salary value either greater than 5000 otherwise less than or equal to 5000, then it looks like it's a obvious condition, always it is true, so I print all the tuples, right? So this where condition doesn't filter any tuple, that is what my intuition. Then 1 2 3 4 5, so I think that it prints 5 tuples, but that is wrong. The reason is, let's evaluate this query. So because of the null values you get unexpected result. So that's why you should know what are the results you get because of null values. So here what I do is I take every tuple and I evaluate where condition. First time 2000 greater than 5000 false, but 2000 less than or equal to 5000 is true. True or false is true, then this tuple will be taken, right? Selected. So this tuple is selected. After that 2 comma 3000, for that salary is 3000, 3000 greater than 5000 false, but this is true, this will be selected. Now when I substitute null, this is a time to substitute null, salary is null when evaluating third tuple, right? So whether it is selected or not, we'll see. Null greater than 5000 is evaluated to what value? Unknown, correct? So null less than or equal to 5000 also, we know that unknown, correct? So remember one thing, null versus any relational operator will be evaluated to unknown logic. So unknown or unknown, already I told you unknown or unknown is unknown. So finally, so this where is evaluated to unknown, but only if where is evaluated to true, we print the tuple. So this tuple will be rejected, similarly these three also. Now only two tuples got selected, then if you count the number of such selected tuples, only two will be printed, right? So the output of this query is simply count the number of tuples, 2 is the output. But you were expecting 5, it's because of null values. So null values are very dangerous, you should be very careful while evaluating the queries. Already I told you how to evaluate queries related to null values, correct? So remember that things, okay? Now we will see aggregate operators. In the presence of aggregate operators, in the presence of null values, how these aggregate operators will be defined, we will see. Remember one thing, that 5 important aggregate operators for us. One is max, correct? Second one min, so average, and sum and count. Alright. So all these aggregate operators simply discard null values. Remember, in the calculation they all discard the null values. If you remember that, it is very easy for you, except count star. If you write count star, then count star counts null values also. Okay. Example. Let's take same problem and we write a query like this. Select count star from employee table. If you write this kind of query, so what happens is, so from employee table there is no where condition, right? Count star, count all the tuples, then 1 2 3 4 5, so it gives you output 5 because null values also will be counted. Whereas if you write this one, select just count on column, let's say salary, count of salaries from EMP. So now you might get a different answer. The reason, so we are counting a salary field, correct? So let's do that. From employee table, so take the salary field contains values like this, 2000, 3000, null, 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 correct? Now count them. Already I told you, every aggregate operator other than count star will discard the null values. That's why these 5 I am talking about. So these null values will be discarded first, only other 2 things will be taken, they will be counted. Then if you count not null values, then only 2 will be printed. Now next one, this is obvious that average comma sum cannot understand null value, correct? Example, you are doing average salary. See this one, select average of salary from EMP table. So to calculate average value, only not null values I can add, correct? But here you have null values also. Then how this query will treat that null values? Simply null values will be, that's why discarded, because null values cannot be added. They are not such kind of things. So that's why it will be 2000 plus 3000 plus null values will not be added. So only 2 things will be added by number of tuples added equal to 2, right? So it will be 5000 by 2, which is nothing but 2500 here. So finally remember, average aggregate function also discards null values. Very simple. Okay, every aggregate function which I explained you, simply they discard null values first, then later in the remaining resultant table, so calculations will be done. Remember it, except count star, but count star counts null values also, right? Example, you have another table like this, only one column salary. Okay, just for imagination, and salary is nothing but 1 comma 2 comma null comma null comma null. For this query, like for this table, if you write select count star, what happens? So select count star from emp, if you write, what happens is, because it is count star, right, it counts all. Star means everything, so count everything. 1 2 3 4 5. This is the only aggregate operator count star which counts null values. That's why answer is 5. Understand? So this is a story about aggregate operators versus null values. Understand? Now we will see one more thing about these null values. That is, you have a query and that you have all operator, we know, right? So in the presence of all operator, in operator and any operator, okay, not in operator, how these null values will be calculated or how null values will affect your logic, we will see. Let's begin with all operator. Example, you have written, I am not writing the query, so I am just writing the part of the logic, like, so where, example, you have like this, where your salary greater than or equal to whatever, all something. Here you have some values, right? In this table, you have null values. So that means salary greater than or equal to all some values here. Here you have null comma 20 comma 30 at this moment. So this salary value is 50. Is this 50 greater than or equal to all? We will see. This is the idea. Left side you have a numerical value, not null value. Right side you have a table. That table contains some null values. Then how such things will be evaluated? If there is no null values, we know that 50 greater than or equal to 20 correct, 50 greater than or equal to 30 correct, and we know the logic, right? But now what happens, we'll see. First of all, 50 greater than or equal to null will be evaluated. Second, 50 greater than or equal to null. Just if really all this, all means what? We have to compare 50 with everything, right? 50 greater than or equal to null, 50 greater than or equal to null, 50 greater than or equal to 20, 50 greater than or equal to 30. That is the meaning of all operator, correct? Now we'll see the truth values. So 50 greater than or equal to null, unknown. 50 greater than or equal to null, unknown. 50 greater than or equal to 20, true. 50 greater than or equal to 30, true. So 2 times it is true, but 2 times unknown. Is it always true? No. But we know that whenever you write all operator, every time the condition should be evaluated to true, but that did not happen here. So finally this expression will be evaluated to non-true. That means it's definitely not a true. So it is definitely, unknown, I can say. Correct? So definitely it is, I mean, you can either treat like unknown, otherwise false, not a problem. But definitely it is not true. Correct? So now at this moment, so where condition will not be evaluated to true. Remember it. But now what happens, we will see. So 50 greater than or equal to all, right? That means 50 greater than or equal to null. So this question you should ask yourself, 50 greater than or equal to null and 50 greater than or equal to null, and if everything true, then only all will be evaluated to true. Third condition is 50 greater than or equal to 20 and 50 greater than or equal to 30. That is the logical meaning of all operator. So 50 greater than or equal to null is unknown, correct? So unknown and anything, already we know that unknown and anything, true or false. So unknown and anything is not unknown. Unknown and, let's see everything, unknown and true and true, right? Now see, unknown and unknown is unknown, unknown and true is unknown, unknown and true is unknown. We know the logical values, right? So that's why finally it is evaluated to unknown, but not true. That's why, so this where condition is now not true. So this tuple will be rejected. Like, so whenever you substitute salary value 50, such tuple will be rejected. Now second thing, sir, what if this itself is null? Simple. Null greater than or equal to all of null 20 30. The question, it is again like this. Just have patience and simply write this expression. Null greater than or equal to null. It is like asking null greater than or equal to null, and null greater than or equal to null, and null greater than or equal to 20, and null greater than or equal to 30. Correct? We'll see one by one. Null greater than or equal to null. It looks like, sir, null greater than or equal to null is true. No. Null, already I told you, when there is a greater than or equal to operator, any relational operator, then when it is a comparison, then there is one null element in that comparison, that always that will be evaluated to unknown. So null greater than or equal to null is unknown. Okay, don't say that, sir, null is equal to null. So even null equal to null is actually unknown. The reason is, do you know that this null value equal to this null value? Both are unknown values. Example, someone's salary is null, another person's salary is null. Can you say that they are equal? They have equal values? No. So that's why unknown. Null greater than or equal to null will be evaluated to unknown, and this is also unknown, right? Unknown and unknown, unknown and null greater than 20, unknown, everything here unknown. So unknown and unknown and unknown and unknown is unknown. So finally, where unknown, right? If it is true, then only we print. That's why such tuple with which you substituted, so that will not be selected, because that truth value which is evaluated here is unknown, but I want true. That's it. In that way we can understand about all operator and null values. Now we will see any operator. What if we have any here? Example, the condition is like this, where your salary greater than or equal to any, and some query here. This query's result is some set of salaries. They are 20, 30, 40, some null values, null, null. Okay. So if there are no null values, we know the logic, right? So if you have null values, what happens? Example, salary value is now something 20. Is this 20 greater than or equal to any of this 20, 30, 40, null, null? Yes. 20 is at least greater than this one. That is enough. Though there are null values, so this 20 is greater than or equal to this 20. So automatically, so this query's truth value will become true. So how to understand this one is, it is like asking this question, 20 greater than or equal to 20 or 20 greater than or equal to 30. There is a or condition between them. When there is all operator, so we have to write conditions and we have to AND them. Here we have to write a conditions and we have to OR them. It is like 20 greater than or equal to 20, or 20 greater than or equal to 30, or 20 greater than or equal to 40 kind of thing. So now, though you have 20 greater than or equal to null condition, that is evaluated to unknown, doesn't matter, because this 20 greater than or equal to 20 is true. So true or unknown is true. That's why this is evaluated to true. Now, second case, what if this salary itself is null? So now this question is, null is greater than or equal to any, at least one of them, we don't know, right? So it is like asking null greater than or equal to 20, unknown. So null greater than or equal to 30, unknown. Say you get unknown, 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 null greater than or equal to null, unknown, null greater than or equal to null, unknown. So they are ORed, right? That is the logic of any. So it is like asking unknown or unknown or unknown or unknown or unknown, which is unknown. That's why. So when there is a null value in the salary field, then this where condition will not be evaluated to true, it will be evaluated to unknown, right? Now we will see in operator and not in operator. Let's try to understand in operator. Example, your query is like this, where salary in some salaries here, that salaries are 1000 rupees, 2000 rupees and null value. Okay. Now the question, example, this salary value is 3000. Is this 3000 in 1000, 2000 null? Absolutely no, right? So false. What about this one, salary is 2000? Is this 2000 in 1000, 2000 null? Yes, 2000 in this one, right? So now in the presence of null values also, this query is evaluated to true. Correct. Now what if this salary is null? So null in 2000, 2000 null, that is the question. So some students think that null in null is true. That is wrong, because here this null is unknown value, some unknown value. So this null is some another unknown value, right? So these two unknown values may not be same. That's why whenever you have a logic like null in null, that means my salary is null. Is this null value is in this null values? No. Though these two, like don't say that. So finally it's like asking this question, is this null, salary null, is equal to this null? So already I told you, comparing two null values with equality will give you unknown result. That's why, so null equal to null is unknown. The only thing you remember, really you want to check whether there is a null value in this group or not, we should write like this. Salary, my salary is null. There is a command, you remember. So like this, is null. If you ask this question, now it's like exactly you're asking, is your salary field is having null value? Don't write equal to. So there are two things. Is my salary equal to null is one thing. Second one, is this salary is null? So there are two things. Okay. Salary equal to null. It's a comparison. When you compare two values, if this salary is null, then null equal to null will be evaluated to unknown. Now, if you write salary is null, yes, this salary field example really this salary is null, then yes, this null I'm saying that my salary field contains null value. Yes. So for if you want to say that, use is null. Okay, but never write equal to. When you write equal to, though left side and right side you have null values, then they will be compared and they will give you unknown result. The logic behind that is, so someone's salary is null value, another person's salary also null value. Then you are comparing them and you are saying that they are equal. No, they are not equal. We can't say. That's why that kind of comparison will lead to unknown. Understand? So this is the only thing. Example, you have a salary field and you want to check whether that salary field has null value or not. Then you write, is this salary is null? Okay, so this is the syntax for that, but not this arithmetic operators. Understand? So this is about in operator and null values, right? So finally, null in, when you have this kind of question, null in some thousand comma null is evaluated to unknown. So null is not thousand, null is not null. It's like asking this question, is this null equal to thousand and is this null equal to null? Is this null equal to thousand? Unknown. At least is this null equal to null? Unknown. Right? That's why overall this query will be evaluated to unknown. That is about in operator. In the same way you can understand not in, there will not be any difference. First of all, think about in operator. So example, in the place of not in, example you want to evaluate a query with not in, don't worry. First check in condition. If in is evaluated to true, not in will be evaluated to false. If in is evaluated to false, not in will be evaluated to true. If in is evaluated to unknown, not in also evaluated to unknown. Remember it. Okay. Example, salary, my salary not in some salaries, let's say 1000 comma null. Okay, 1000 and null. So how this where condition will be evaluated? So where salary not in 1000 null. Example, that salary value is 2000. My salary 2000 not in this 1000 and null. So 2000 not in 1000, correct, right? And 2000 not in null. First of all, think about in. Is this 2000 in 1000 comma null? 2000 not 1000, 2000 not null. So it is evaluated to unknown, correct? If it is in operator. But we have not in operator. Not of in. So in gives unknown, not in gives not of unknown, which is again unknown. That's why I want to say that now this expression's truth value is unknown, right? Nobody knows. The question is 2000 not in 1000 comma null, unknown. Okay, so you remember it. So in that way, you can understand about not in operator. Let me introduce you join operators. So in SQL, we can write join operators explicitly. So we'll see one by one. There are two kinds of join types. One is inner join, second one outer join. In outer join, we have three variations, left, right, full. We will see one by one. And join condition. How you want to do join? Example, let's say you want to do inner join, but how you want to do? Do you want to do natural join? Otherwise, do you want to do, a conditional join, like you want to specify the condition, then we can do it. Third one, so using the column names, that means, do you want to equate these particular columns? For that we have, variations. Finally, what I want to say is, you can specify the join type and you can specify join condition. So finally we have to take one of the join type and one of the join condition. To understand them clearly, it's a informative thing, right? So we'll take some examples and we'll see what happens and what is the purpose of each and everything. Let's take first inner join. Inner join versus natural. So how to write the syntax? Usually we have to specify this join in from class. In from class, I am assuming that we have two tables T1 comma T2. Then you write like this. I am specifying now inner join from T1 like this. Inner join T2. When you write like this and if you don't write anything else, then it is like Cartesian product. So there is no effect. So T1 inner join T2 will result Cartesian product. But you can use join condition. One is natural. So way to write natural I will tell you. So from, if you write natural here, from natural T1 natural inner join. Natural inner join. So if you write like this, what happens is, so natural join will occur. So you know what is natural join in relational algebra, same thing will happen. Example, you have T1 and T2, then all the common columns will be equated. Example here, A comma B are the common columns, right? They will be equated, you see. So AB values are here in this tuple 1, 2, here also 1, 2. Then the result will be like this. I am writing the output if you write like this. If you write a query, so you know how what to write here. Example, select everything, whatever. So if you write select star, what happens, we'll see. Select star from T1 natural inner join T2. Then what happens, all the columns will be printed, but since it is natural join, so common columns will be printed only one time, AB. After that, let's say D, table number 1's different columns and table number 2's different columns, C. Now values are, since this one matches with this one, this two matches with this two, so A, B values are matched, then it will be 1 comma 2 here, and what is the corresponding D? 1, and what is the corresponding C? 2. So this is the result of natural inner join. Sir, what about this one? 2, 3 versus 1, 2. 2 doesn't match with 1, correct? So that's why. So it's like a Cartesian product, but common columns will be equated. So only this tuple will be equated to this tuple because there is no other tuples which match, right? Here 1, 1, 2, 2. You know natural join. So this is about natural inner join. Now we'll see what is this on predicate. So rather than writing natural, what you can do is we can write predicate also. So syntax will be from select star or anything whatever you want from T1, you know, inner join. You write inner join simply. So already we have here, right? Let me take it. So from T1 inner join T2, so that predicate on which column you want to apply the condition. Maybe so you want to do like this, T1 dot A greater than T2 dot B, something like this. Randomly I am doing that. We'll see what happens if I do that. So what happens if you do that, T1 and T2 will be inner joined, that means Cartesian product will be done, and after that T1 dot A greater than T2 dot B's condition will be evaluated. Only that tuples which satisfy this condition will be taken. It is like now, so you get A comma, I am just showing the result. If you write star, all the columns will be printed A, B, D, after that A, B, C. First of all, think about Cartesian product. In the Cartesian product, what are the tuples will be printed? One is 1, 2, 1, 1, 2, 2, correct? 1, 2, 1, 1, 2, 2. But here we have a condition. What is that condition? T1 dot A greater than T2 dot B. So that is called predicate. So you can apply any number of predicates. So you can write on T1 dot A greater than T2 dot B and T2 dot C greater than, you know, T1 dot B, something, whatever. Okay, but I'm mentioning only one condition. You can mention any number of conditions. Only the tuples which satisfy this condition will be taken. Example here, what is T1 dot A? 1. What is T2 dot B? 2. Now the question is 1 greater than 2, false. Then this tuple will be rejected, don't take. So next combination we'll see this combination. 1, 2, 1, 7, 9, 3. Will it be printed or not based on this condition? T1 dot A for first tuple 1 and T2 dot B 9, correct? So is this T1 dot A 1 greater than 9? No. Then this tuple this combination. 1 greater than 7 false, nothing will be taken. Next, this one, this tuple versus second tuple versus first tuple, but the only condition is t1 dot a greater than t2 dot b, t1 dot a 2 greater than t2 dot b. No, so unfortunately, so nothing will match here also. So this versus this also will not match, so you have to try. Then I am going to third tuple versus first tuple. It is like Cartesian product, but only thing is this condition should be matched, right? So t1 dot a, what is t1 dot a in this combination? 3, right? And what is t2 dot b? 2. 3 greater than 2, yes. So now first time condition is satisfied, only that combination will be printed. What is that? 3 4 1 1 comma 2 comma 2. That's it. Out of 3 into 3, 9 tuples, only one tuple will qualify this condition. That's it. Later, so this star means all the columns will be printed. So this is about inner join with some predicate. So far you learned natural inner join, after that inner join with predicate. Now we'll see inner join with using condition. So what is using is, rather than writing the condition, you can just mention the column names where you want to equate them. It is about equality. It is like equijoin, I can say. So example, you want to join these tables based on some columns. That columns you should mention. Okay, so let's start with first syntax. How to specify using, I will tell you. Example, select star from t1 inner join t2 using. Here we should write using, let's say, columns a comma, let's say, what are the only common columns we should specify. What are the common columns we have? One is a, one is b, correct? Then you can write using a. That's it. In the braces you write like this, using a. When you do this one, what happens is, so here it will be a, because you are equating a, that column a will be printed only one time, then all other columns will be printed a, b, d, then b, c. Try to understand why we have written only one a, because we are going to equate that column a's. When you equate column a's, they will have same values, right? That's why only one time it will be printed. So I can say that this is common column, right? So we'll see the output now. So how output will be evaluated? See, one, it is like writing t1 dot a equal to t2 dot a, that's it. So there is a relation between using and predicate. In predicate we mention the condition. Here we simply just write the column names. So if example, if I write column name A, then the column A should be common in these two, and that column will be matched. That means equated. That means t1 dot a equal to t2 dot a. Let's try that. t1 dot a equal to t2 dot a. Yes, then this combination will be taken. What is that? 1 to 1, 1 to 2. So in that 1 to 1, 1 to 2, what is that common a value? 1. Then b2, d1 and b2, c2. Next, will it match this one with any of other things? No, right? Similarly, 2 doesn't match anything, 3 doesn't match anything. So only one thing will be printed, that is 1 to 1, 1 to 2. Understand? So this is about T1 inner join T2 using A. That means column A value will be matched. Now the final one is, so let's try to write using with two columns, like using A comma B. But don't write A comma B comma C. Why, sir? If you write A comma B comma C, then A, B, C should be common columns. A, B, but only A, B are common. So at most we can write A comma B. When you mention like this, what happens is same story. These A comma B columns are common, which are printed only one time. Then D, after that C. Okay. So A, B, D, C. Now what are the A, B values? See here. This tuple versus this tuple. If you do Cartesian product, there will be 9 tuples. But my idea is what? Because I used using, then it is like checking T1 dot A equal to T2 dot A because of this A, and T1 dot B equal to T2 dot B. I want a combination out of 9 where T1 dot A equal to T2 dot A. See, T1 dot A equal to T2 dot A. T1 dot B equal to T2 dot B. So only one tuple will match, that is 1, 2. See, AB values are 1, 2. And what is D value? 1. And C value is 2, of course. So 1, 2 comma 1, 2 will be printed. So this is about T1 inner join T2 using A comma B. right? So far we learned all the combinations with inner join. Inner join natural, inner join with predicate, inner join with using. Understand? Now let's see what is this outer join, how to specify that condition. So generally we specify outer join like this from T1 outer join. So let's take first left outer join. T1 left outer join T2. But here one thing is, so either we can specify natural, otherwise predicate or using. Let's start with natural first. So if I write natural here, that is one way of specifying the join type, correct? Sorry, join condition from T1 natural left outer join T2. Okay. So what happens, we'll see. Syntax is what? From T1 natural left outer join T2. Okay. So when you do that, again common columns will be automatically equated. Let's do that. See here, the data is 1 to 1 versus 1 to 2, correct? Then output will be, because it is you wrote natural, then common columns will be written only one time. What are the common columns? A comma B, correct? After that the extra column here is D, extra column here is C. Okay, now it is natural. Let's blindly do. So what is the difference between natural inner join and natural outer join? I will tell you. First of all, natural left outer join is nothing but that contains results of inner join. Blindly do inner join first. Then if you do inner join, you see this one matches with this one, this two matches with this two, right? Then output will be 1 comma 2 and 1 comma 2. So D value 1, C value 2. Okay, let's modify some data here. If I take here, let's say 2 comma 3. So what happens if I do that? This 2 matches with this 2, this 3 matches with this 3, correct? So that's why natural means common column should be equated. So here common columns are A comma B, they are equated. So they will be matched, correct? So 2 will be matched with 2, 3 will be matched with 3. Then you get another tuple called 2, 3, A value 2, B value 3 and D value 2 and C value 3. In that way, so it's like inner join, natural inner join. But what is this outerness? I will tell you. Whenever you mention outer join, especially left outer join, then all the, see here in the table result, what are the attributes? If you see ABD values, generally we have 1 to 1, 2, 3 to 3, 4, 1, right? Out of them, how many are participating in the join? See, 1 to 1 participated from T1 side. So this is called left table. In the left table, we have 1 to 1, 2, 3 to 3, 4, 1, right? But only 1 to 1 and 2, 3, 2 got participated. But 3, 4, 1 is not participating because 3, comma 4 are not matched with any of right side. So left outer join is specially for such values. What you do is, since this 3, 4, 1 is not matched with anything, blindly write it 3, 4, 1. Sir, what about C value? For that C, we write null. Since we know what is null, right? So here we write null. So this is called left outer join. Left outer join is nothing but it is a inner join followed by we write all the remaining tuples of T1 in the table. Okay. So similarly, we'll see now T1 right outer join, especially natural right outer join. Okay. Let me write like this from T1 right natural right outer join. If I write this right outer join T2, if I do this, what happens, we'll see. First of all, inner join will be done. So T1 inner join T2, especially natural inner join. So what is natural inner join? Natural inner join is nothing but it equates common columns. So let's equate the common columns. What are the common columns here? One is 1, 2, second one 2, 3 as usual, right? What are the attributes in this result? Since it is natural, common columns will be printed only one time, A, B, after that D, after that C. This is the result structure. And what are the values you get? One is C, 1, 2 versus 1, 2, correct? 1, 2 and D value 1, C value 2. Second one, this 2, 3 matches with this 2, 3, then you get 2, comma 3, comma 2 matches with 2, 3 matches with 3, followed by this C comma D values, D comma C values. What is D? 2, C value 3. So this is inner join. But what is right outer join is, once this is done, so take the right side table and just see the ABC combinations which did not participate in the join. Example, we have 1, 2, 2, 2, 3, 3, 6, 7, 1. Focus on ABC. ABC. 1, 2, 2. 1, 2, 2 finally participated. Next, you see ABC. 2, 3, 3, right? So 2, 3, 3 also got participated, but 6, 7, 1 is not participated. Then when we do outer join, especially right outer join, that right side tuples will be replaced. That means they will be filled. 6, 7, 1. Then when you do that, since this join is about all the attributes of T1 and all the attributes of T2, right? Then when you fill only 6, 7, 1, this portion is what? This portion is about T1's values, right? What should I write? Generally we write null. So that is the concept of right outer join. That means we are finally forcing all these tuples to participate in the join. That is right outer join. When you force all the left side tuples to participate in the result, we say that is left outer join. Sir, what is full outer join? By this time you should understand. In full outer join, we do inner join. After that, all the tuples of left side will be written along with null values of right side table. Then all the right tuples of T2, that means all the right side tables values will be added along with all the null values at left side table. That's it. We'll see one more example of full outer join. Okay. Now we'll see T1 natural full outer join of T2 for different tables. Okay. Now in these tables T1 comma T2, we have A, B, C columns here, A, D, E columns here. Only common column is A. Okay. When you do natural join, what happens? We'll see. So common column will be equated, correct? So what happens? This 1, will it match with anything? No. What about 2? Yes, this 2 matches with this 2 first, correct? So output will be, because it is natural, common columns are only A will be equated and only one time it will be written. Then output will be like this: A, B, C. Then remaining columns of T2, D comma E. So you know the reason why A is repeated only one time, because natural join means common columns will be equated, then that common column which is A will have same values. That's why to repeat it two times? That's why only one time it will be repeated. Now it is like a Cartesian product. Imagine, let's say you are doing Cartesian product. Then how many tuples will be printed? 1, 2, 3, 4 versus 4. 16 tuples supposed to be printed, but here common columns will be equated. Whenever they are equal, then only that such combinations will be printed. Example, this is one normal combination, but here you have 1, here you have 2 in the common column, then they don't match, then this combination will not be printed. That's why, so 16 tuples will not be printed, only tuples where values, common columns are matched will be printed. Example, here you see 2. So this 2 matches with this 2, then this combination will be printed. What is that? 2, 4, 7, 2, 3, 4. 2, 4, 7. Of course 2 is already printed. 3, 4. Next, this 2 matches with this 2. Then 2, 4, 7, 2, 6, 9. 2, 4, 7, 2, 6, 9. Right? So that means 6, 9. Anything else? That's it. So this is about natural inner join. So far whatever you got the results, right, it is natural inner join. But what is the specialty of this outer join? Now, so we are going to see the participation of T1 tuples, all the T2 tuples. It is full. Full means left outer join plus right outer join. That means focus on the tuples which did not participate in the join. Example, here 1 to 5 is not participated in the relation, right? Then you have to write it like this: 1 comma 2 comma 5, ABC combination. So see, full means what? First do left outer join followed by right outer join. So what is left outer join? In left outer join, all the left side tuples should participate here, 1 to 5, along with this DE values null comma null. So next, anything else? Now 1, 2, 5 participated, 2, 4, 7 participated. Anything else? 1, 3, 6 is not participated. Then you write it 1, 3, 6 along with null values. So I am doing left outer join work. Full outer join is nothing but left outer join plus right outer join. So then later we have to add 359, correct? So 359 along with null comma null. Okay, now so far we have seen just this is the result of left outer join. Now we'll check whether it is left outer join or not. So if really it is left outer join, all the tuples should participate in the relation. Yes, 247, 359, 136, then 125, correct? Now do you see here all these tuples are participating in the relation? See 2, 3, 4. We have C. Only focus on ADE. ADE. 234 is participating and 269 is participating. But 569, 736 are not participating, right? So in right outer join, we should add them. Since it is full outer join, that means left outer join, right outer join. Now let's do right outer join. If it is really right outer join, what will be added? I show here A, B, C, D, E. So ADE tuples, this one, right? 5, 6, 9 should be added. 5, 6, 9 along with BC values. What are the BC values? We don't know. That's why we write null comma null. Next, what is the next tuple which did not participate? 7, 3, 6. Write 7, 3, 6 along with null values. So this is called right outer join. Now full outer join is nothing but left outer join for plus right outer join. So this is a result. So far you learned what is natural left outer join, what is natural full outer join, what is natural right outer join. Now we will see other combinations. That means outer join versus predicate, outer join using columns. Okay, so they are quite easy, but for completeness let me cover that also. Now we'll see left outer join versus predicate. So here select star from table 1 left outer join T2 on T1.C less than or equal to T2.D, right? So this kind of conditions we write on predicate. So second model. So we know that there are three models. One is outer join versus natural, outer join versus predicate, outer join versus using. So already natural is done. Now we are using on predicate. So this predicate is a condition. So now we are going to join the tables based on this condition. Okay. Sir, what is the difference between again inner join and this outer join? In left outer join, we do like inner join first. After that, the tuples which are remaining in left side table will be added as we did already in natural left outer join. We'll do that now. So let's blindly follow first join, inner join. Okay. Then after that we see the extra thing which we have to do for left outer join. So condition is what? T1.C less than or equal to T2.C. Then T1 and T2 will be joined using this condition. T1.C less than or equal to T2.D. See, T1.C less than or equal to T2.D. Correct. 3 less than or equal to 4. Then, so output will be A, B, C followed by A, B, D. Since it is not natural join, all the columns will be printed, right? So now this is the output structure. First, T1.C less than or equal to yes. So here C and D, 3 less than or equal to 4. Then output is 1, 2, 3, 2, 3, 4. Now second combination. 3 versus C. Always we have to compare C and D. 3 versus 6. 3 less than or equal to 6. Correct. Then 1, 2, 3. 2, 3, 6 will be printed. Then after that, see here. 3 versus 9. 3 less than or equal to 9. Correct. So 1, 2, 3. This 3, 6, 9 will be printed. Okay. So it is 3, 6, 9. So here one thing. Here 3 less than or equal to 6. It is actually 1, 5, 6. Correct. So let's write it. 1, 5, 6. Then finally with 1, 2, 3 we wrote 2, 3, 4, 1, 5, 6, 3, 6, 9. Now with 5, 4, 9, let's try 2, 3, 4. T1.C should be less than or equal to T2.D. So here T1.C 9, is it less than or equal to 4? No. 9 less than or equal to 6? No. 9 less than or equal to 9? Correct. So new tuple will be added is, so 5, 4, 9 versus 3, 6, 9. This is the only combination. So later 6, 3, 7 versus 2, 3, 4. 7 is what? T1.C. T1.C here and this is T2.D. So 7 less than or equal to 4, false. So this combination will not be printed. Now 7 less than or equal to 6, false. This combination will not be printed. So 7 less than or equal to 9, correct. So new combination will be 637 followed by 369 will be printed. So this is the output of just join, right? Join followed by condition. But what is special in left outer join? In left outer join, what we do is, if any tuple does not participate in the join, we add it. Let's focus. 1, 2, 3 participated. 5, 4, 9 participated. 6, 3, 7 participated. Nothing to add. Don't add anything. So here it is like, the result is like simply inner join, correct? Now we'll see right outer join. What if it is right outer join? Okay. Now condition, let's take different one. So let me take a condition like T1 right outer join T2 on, let's take T1 dot B greater than T2 dot B, and another condition we'll take T1 dot A less than or equal to T2 dot D. Any number of conditions we can write. Okay. So output will be again 6 columns, A, B, C, A, B, D, right? So this is a structure of the table. Let's begin. Condition number 1, T1 dot B greater than or equal to T2 dot B. Let me mark the columns. So T1 dot B should be compared against T2 dot B. Second condition is, this is condition number 1. What is another condition? T1 dot A, which is less than or equal to T2 dot D. These two conditions. So here less than or equal to condition, and here we have greater than condition, T1 dot B greater than T2 dot B. Let's see. Start with this combination, this and this. T1 dot A less than or equal to T2 dot D. See, A versus D. 1 less than or equal to 4. Correct. Second condition is B versus B. 2 greater than or equal to 3. 2 greater than 3. False. So one of the condition is false. Then tuple will be rejected. Now let's take this versus this. In this one, see, B and B. 2 greater than 5. False. So that combination also will be rejected. 2 greater than 6 is rejected, right? So everything with 1, 2, 3 combination got rejected. Now we'll see 5, 4, 9. So here you see 4 greater than 3, correct. T1 dot B greater than T2 dot B, and T1 dot A, which is 5 less than or equal to T2 dot D. So in this one, T2 dot D is 4, right? So 4 less than or equal to 4. So that is what we have to check. T1 dot A less than or equal to T2 dot D. So T1 dot A, which is nothing but 5, is it less than or equal to T2 dot D, which is 4? 5 less than or equal to 4, false. So that will not be taken. Now next, this combination we'll see. 5, 4, 9 versus 1, 5, 6. T1 dot B, which is 4, greater than T2 dot B. Yes, 4 greater than 5, false. So don't take it. Now try this combination. Second tuple versus third tuple. 4 greater than 6, wrong. So 4 greater than 6 is false. This tuple also will be rejected. If you see finally, so nothing will be selected, because at a time T1 dot B greater than T2 dot B and T1 dot A less than or equal to T2 dot D will not be true. So that's why nothing will be selected. Once it is done, so far just we have seen inner join, but actually it is right outer join. In right outer join, what we have to do is, whatever the result you get, once you get it, then we have to fill the entries from the right side. Go to the, since it is right outer join, go to the right side table. In that 2, 3, 4, 1, 5, 6, 3, 6, 9, nothing is in the result. That's why we have to add them. Add 2, 3, 4, and on behalf of ABC we should write null, null, null. Similarly we write 1, 5, 6 with null, null, null. So after that 3, 6, 9 along with null, null, null. If this is left outer join, then we write 1, 2, 3 null, 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 5, 4, 9 null, 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 6, 3, 7 null, null, null. If it is full outer join, then we write like this: null, 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 2, 3, 4, 1, 5, 6 nulls, 3, 6, 9 nulls, followed by 1, 2, 3, 3 nulls, 5, 4, 9 nulls, 6, 3, 7 nulls. That means it is a combination of left outer join plus right outer join. That's it. So finally you learned the right outer join, otherwise some outer join versus predicate. Now the final condition is outer join versus using. So how it will work, we will see. Of course that is very easy. The syntax will be like this: select star select star from table name is what? T1, right? So T1, let's use full outer join. Full outer join T2. Now using condition is, so I'm just teaching you how to use using. So using some columns. So tell me some common columns. We have only two common columns, A comma B, right? Anything you can use. Let's use B. Using B. Whenever I write using B, then this common column B will be equated. That's it. Let's equate that common column now. So this is T1, this is T2. Tell me what is the common value here. See here, 3 versus 3, correct? Only one time. Then output will be A, B, C, A, B, D, which is quite usual. But since we are using common column B, that common columns, see, don't write B two times. Just for illustration purpose, I'm showing it. But only one time we should write. One B should be eliminated because both B's will have same value. Now what is that combination now? 3 versus 3, same, correct? Then it will be like this, 6, 3, 7, right? So 2, 3, 4, 2 and 4, that's it. So it is inner join, but actually ours is outer join, full outer join. So because of full outer join, what we have to do is, once this common columns equation is done, then we should go to the remaining tuples in T1. See, full outer join. First of all, go to the left side table, do left outer join. Left outer join means what? What are the tuples did not participate in this join? 5, 4, 9, 1, 2, 3 at left side. That's why we write it like this. 1, 2, 3, 5, 4, 9 along with null, 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 null. Okay, actually this dash means null. Now after that, since it is full outer join, go to right side. Which tuples did not participate in this relation? Only see 2, 3, 4 participated, correct? 1, 5, 6, 3, 6, 9 are not participated. Then we write like this, 1, 5, 6. So A value 1, B value 5 and D value 6. 1, 5, 6 with along with null, null. Okay, then one more thing is 3, 6, 9 also did not participate, right? A value 3, B value 6 and C value 9. Along with that, this, what about A comma C values? Null comma null added here. Okay, so this is the result. So finally here it will be null and null. This is about full outer join using condition. Once you understand, on predicate, you can understand using also, not a big deal, because already we have seen using condition, using inner join, right? In the same way we have to do, but the speciality of this full outer join, left outer join, right outer join is any tuple from table number 1 did not participate, we add it in left outer join. Any tuple which did not participate in right side table will be added in the right outer join. In full outer join, we write tuples of which are not participating in join from left side and from right side along with the null values at counterpart. So this is all the join operators. Okay.